This is 4.5. May I please have some more? Elvira, the cafeteria manager, has to be careful with her spending and manages the cafeteria so they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. So, number one reads Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? So it's telling us to write and solve an inequality that models the situation. So the first thing we have to identify is our rate of change and our starting amount. So because it's charging 35 cents per carton of milk, that per carton of milk lets us know that that is our rate of change. And then we have a delivery charge of $75. So in the beginning, you have to pay your delivery charge and then an additional 35 cents per carton of milk. So our inequality is going to be 0.35. Because it's our rate of change, it's touching X plus the $75 delivery fee. And then it tells us that she has $500 in her budget. So when you budget a certain amount of money, you cannot spend more than that amount. So for our inequality, we want the amount she spends to be less than $500, but she can also spend all of the $500, so it's less than or equal to. So with this budgeted $500, that means she can spend up to $500. So then it says, describe in words the quantities that would work in this situation. So the only numbers that make sense are whole numbers. Because you're not going to buy half of a carton of milk or 3/4 of a carton of milk. So we want to figure out how many cartons of milk can she buy. Oh, I forgot one, sorry. And it's positive numbers. So whole numbers and positive numbers, because you cannot have a negative number of cartons of milk. So then it says, write your answer in both interval and inequality notation. Well, we don't have an answer yet. We still have to figure out the answer to the question. What is the maximum number of milk cartons that she can buy? So we have to solve our inequality. So we have 0.35x plus 75 is less than or equal to 500. So the first step is to subtract 75 from both sides. We're left with 0.35x equals 425. And then we divide by 0.35. And x equals, or not equals, my apologies, x is less than or equal to 1,214. So it says write your answer in both interval and inequality notation. So remember, this is talking about those cartons of milk. So the smallest number of cartons of milk you can get is 0. And the maximum number of cartons of milk you can get is 1,214. So as an interval, it's those hard brackets because 0 is a solution to this. You can just pay for delivery, which doesn't really make sense, but you can get 0 cartons of milk and you can get 1,214 cartons of milk and spend a maximum of $500. So then for inequality notation, we have 0 is less than or equal to x, which is less than or equal to 1,214. On to the next problem. Students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. For how many days will her ranch dressing supply last before she needs to reorder? So again, we have to look for our rate of change. So the students eat 2.25 gallons per day. So that means it's decreasing by 2.25 gallons. So we have negative 2.25 gallons per day. And she starts the year, so our beginning amount is 130 gallons, a positive 130 gallons. And it says she wants to have at least 20 gallons left. So 20 is the smallest amount she wants to have left. So our inequality is going to be greater than or equal to. So the smallest amount, at least 20 gallons. 20 is your smallest amount you need to have before she reorders. So again, describe in words quantities that would work in this situation. This will be positive numbers because you cannot have a negative number of days. And then we also want to use whole numbers for it because she's not tracking this every second of every day. She's seeing how much she has left at the end of each day. So it says write your answer in both interval and inequality notation, which means we need to solve it first. So the first step is to subtract 130, and we're left with negative 2.25x is greater than or equal to negative 110. The next step is to divide by negative 2.25. And remember, when you multiply or divide to move a negative, you must flip your inequality symbol. So because we divided by that negative, your symbol has to change directions. And we're left with 48.8. So that means it's up to 48.8 days, but we already said that whole numbers is all we can have. So if we look at it, x has to be less than 48.8, which means we're going to round down to 48. So our interval notation is from day 0 to day 48. And our inequality is 0 is less than or equal to x, which is less than or equal to 48. So the reason, again, that we round down is because your x value has to be less than or equal to 48.8. So we cannot round to 49 because that's not less than or equal to 48.8. Okay, on to the next one. The prices on many of the cafeteria foods change during the year. Elvira finds that she has ordered veggie burgers 4 times and has paid $78, $72, $87, and $90 on the order. To stay within her budget, Elvira needs to be sure that the average order of veggie burgers is not more than $82. How much can she spend on the 5th order to keep the average order within her budget? So because of this word average, that means we're going to add up all the prices of the veggie burgers, and they need to be no more than $82. So our first veggie burger order, there's our first 4, and then the 5th is our unknown. So when we write our inequality, we have 78 plus 72 plus 87 plus 90. And then that 5th order is our unknown, so we're going to call it x. And when you find the average, you add up all of your values and you divide by the total number of values. So we have 5 orders, $78, $72, 87, 90, and our unknown fifth order. And it says that it wants to be not more than, which means it's going to be less than 82. Now, because it wants to be not more than, it can also be equal to that 82. Okay, it just cannot be more than $82. So the type of quantities that would make sense are whole numbers. Actually, this one can have decimals, but it's only a decimal to 2 places. Because we're talking about money here. And positive values. Positive numbers. Because you're not going to pay a negative amount of money for an order of veggie burgers. So the next thing we have to do, like on all of these, is actually solve our inequality. So the first thing I want to do is combine like terms. So 78 plus 72 plus 87 plus 90 is going to give me 327, and then plus that fifth order x divided by 5 is less than or equal to 82. So our first step is to multiply both sides by 5 to get that number off the denominator. And we're left with 327 plus x is less than or equal to 410. So when we subtract that 327 from both sides, we're left with x is less than or equal to 83. So that means she can spend $83 or less on that last order to keep the average of those orders no more than $82. So in our interval, she can't really spend 0 on an order, but we include it because it's part of that range of values. And then the maximum she can spend is 83. And our inequality 0 is less than or equal to x, which is less than or equal to 83. On the next problem, it says Elvira can purchase ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on ingredients and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas rather than buy them ready-made? So I'm going to differentiate. We want cheaper. So it's going to be less than. So we want to figure out when is the cafeteria making the pizzas less than the ready-made. So I'm going to put, cafeteria made, just as a note to myself. Cafeteria made will be less than ready-made. We want to find out when will the cafeteria made be cheaper than the ready-made. So when we write our inequality, we have to compare these two parts. So it says Elvira can purchase the ready-made for $14.50 each. So that's $14.50 per pizza. And then if she makes them in the cafeteria, those cafeteria made, she can spend $44.20 on ingredients and $6.25 per pizza. So our rate of change is the $6.25 per pizza plus the $44.20 on ingredients. And we want to know when is cafeteria made less than the ready-made. So some values that would make sense is whole numbers again, because we're not selling half of a pizza. And positive numbers, because you cannot buy a negative number of pizzas. You cannot sell a negative number of pizza. So when we solve this, we start off with our our $6.25 plus 44.20 is less than 14.50. X. Sorry about that. Let's add that in. Ran out of room. Okay. So at this point, we are going to subtract the 6.25x because on the right side, there are only x values. So you have to combine your like terms. We've got to get all of our x's on one side, all of the numbers without an x on the other. So the easiest way to do this is to subtract the 6.25x. So we're left with 44.20 is less than 8.25x. Last step, we have to divide by the 8.25 in order to isolate x. And then we have 5.36 is less than x. So on this one, we have to figure out how we're going to round it. Another way you could write this, if you wanted to flip it around, is make sure that the inequality symbol is still open towards the x, not the 5.36. So to figure out how we have to round this, we've got 5.36 and x is larger than 5.36. We already said that whole numbers are what makes sense. So we have to use 6 as our rounded value because 6 is more than 5.36. We can't round down to 5 because 5 is not more than 5.36. So if x is bigger than 6, greater than 6, that means it can go from 6 to infinity. So from 6 pizzas moving forward till the end of time, it is cheaper to make the pizzas in the cafeteria than to buy them already made. Now with this 6, we can actually use a hard bracket because that value is bigger than x and it is a value, it's bigger than 5.36 and it is a value that makes sense in our situation. And then we can use the parentheses on the infinity side because you can't reach infinity. It's not a value that you can plug into a situation and see if it makes sense. So as an interval, you may see it as 6 is less than or equal to x, which is less than infinity, or x is greater than or equal to 6. Those two are equivalent. All right. Next to last problem. It says Elvira is comparing prices on 2 different suppliers of fresh lettuce. Val's Veggies charges $250 for delivery plus $1.50 per bag of lettuce. Sally's Salads charges $100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for Val's Veggies to be the cheaper option? So Val's Veggies to be cheaper than Sally's Salads. So I'm going to go ahead and write that down just like we did on the one before. We want Val's to be less than the cheaper option to Sally. So now that we know which way our symbol is going to go, we need to plug in our values. So reading back through, Val's Veggies charges $250 for delivery and $1.50 per bag of lettuce. So there's our rate of change because of that per, each, every. So we have $1.50 per bag of lettuce plus the delivery fee. And I did that in the wrong color. And we want that to be the cheaper option, so less than Sally's Salads. So Sally's Salads charges $100 for delivery plus $4 per bag. So $4 per bag plus $100 for delivery. So what kind of quantities work? We can't buy half of a bag of lettuce, so we want it to be whole numbers. You're not going to buy a negative number of bags of lettuce, so we want positive numbers. And then it wants us to actually solve this so we can write our equation, our inequality, our answer to the inequality. So we have 1.50x plus 250 less than $4 x plus 100. So let's get all of our x's on one side. I'm going to move mine left. You may move yours to the right if that's what you wish. So then we have negative 2.50x plus 250 is less than 100. Next, we have to move our numbers, so I'm going to subtract the 250 from both sides, and I have negative 2.50x is less than negative 150. So the last step, divide by negative 2.50. And remember, when you multiply or divide to move a negative, like this one down in the bottom, you must flip your inequality sign. So what once was less than now becomes greater than because we divided by that negative. So our x value is going to be greater than 60. So to write this as a interval and an inequality, since x is greater than 60, 60 is our smallest amount. And it can go on forever. Now, because it's just greater than, not greater than or equal to, we have to use the parentheses. And the two different ways that we can write our inequality is that 60 is less than x, which is less than infinity, using the number straight from your interval, or you can just put x is greater than 60. They mean the same thing. Okay, so on this next one, it is for my honors group only. So if you are not in my B3 class, you can go ahead and skip this problem. You can end this video and go on to the next one. So for my honors kids, each student that buys school lunch pays $2.75. The cafeteria typically brings in between $1,168.75 and $1,438.25. How many students does the cafeteria usually serve? So we know that it's going to be $2.75 per lunch. Now, the lower end of the amount that they bring in is going to be $1,168.75. And the upper end is going to be $1,438.25. So we have the amount that they pay, that $2.75 between that lowest value and that greatest value, almost like our inequality notation in our answers. So the way we solve this is we break it down into two chunks. So we have the first chunk is the 1,168.75 is less than or equal to 2.75x. And we solve that. So divide by 2.75, 2.75, and then we find out that 425 is less than or equal to x. That means the smallest number of people that they serve in that cafeteria is 425. So then we have to solve the other half. So we have 2.75x is less than or equal to 1,438.25 because that's the amount that they bring in. So when you divide by the 2.75 on both sides, we end up with x is less than or equal to 523. So the type of numbers that make sense in this situation are whole numbers Because we're talking about how many students, it's also positive numbers, positive and whole numbers. So our interval is that smallest amount. The smallest amount of people that they can serve is 425, and the greatest number is 523. And because those are the smallest and the largest number of students, we use the hard brackets. For an inequality, 425 is less than or equal to x, which is less than or equal to 523.